हेलो डियर स्टूडेंट्स। आज हम लोग एक टॉपिक है व्हीटस्टोन ब्रिज, उसके बारे में थोड़ा पढ़ते हैं। दिस इज द एप्लीकेशन ऑफ किरचॉफ्स रूल्स एंड व्हेन वी आर टॉकिंग अबाउट द व्हीटस्टोन ब्रिज, you have to first of all draw a diagram like this. You can draw this neat and clean diagram to represent Wheatstone bridge. This is the battery. EMF is provided, potential difference is provided. Then we are having two resistance R1 R2 connected with point A, and this in this arm AD, if resistance is R1, current I1 is flowing, and in this arm AB, resistance is R2, I2 is flowing. Then point B and point D are connected by a galvanometer. Then point B and C are connected by an unknown resistance R4, which we need to find out. We can assume here I4 current is flowing from B to C. Then we are having a standard arm in which resistance R3, and from D to C current I3 is flowing. So this kind of diagram you have to make for Wheatstone bridge. Now how this works. So Wheatstone bridge, the bridge has, we are having four resistors R1, R2, R3, R4 across one pair of diagonally opposite points A and C in the figure. A source is connected. This AC is called battery arm because in the in between the points A and C we are connected the battery, so that's why we are calling it as a battery arm. Between the other two vertices B and D, a galvanometer G, which is a device to detect current, is connected. So जो B और D को कनेक्ट वाली करने वाली लाइन है उसको हम लोग क्या बोल सकते हैं, गैल्वेनोमीटर आर्म. सो बेसिकली हम क्या सकते हैं, हमारे पास चार रेजिस्टर्स हैं इस सर्किट डायग्राम में, R1 R2 R3 R4. इसमें से आपको तीन वैल्यूज पता होंगी. फॉर एग्जांपल आई एम सेइंग R1 पता है, R2 पता है, R3 पता है. नाउ unknown resistance is R4, so we need to find that value of R4 using Kirchhoff's rules. And again we are having 2 points AC diagonally opposite. In between them हम लोगों ने एक बैटरी को ज्वाइन किया हुआ है, तो इसीलिए इसका नाम हो गया बैटरी आर्म. बी और डी पॉइंट्स को जो डायगोनली अपोजिट है उनको कनेक्ट किया गया है विद द गैल्वेनोमीटर. गैल्वेनोमीटर एक डिवाइस है जो डिटेक्ट करता है करंट, तो इसीलिए उसको हमने बोल दिया गैल्वेनोमीटर आर्म. So this kind, you can say, this is kind of construction for meter Wheatstone bridge. Next, for simplicity, we assume the cell has no internal resistance. So here we need to write, हमें पता है जो भी कोई सेल होता है उसका EMF अगर E है तो उसका एक इंटरनल रेजिस्टेंस स्मॉल r भी होता है. बट इन दिस केस चीजों को सिंप्लीफाई करने के लिए हमने R को 0 ओम अज्यूम किया हुआ है. In general, there will be currents flowing across all the resistors as well as current Ig through a galvanometer G. But we are interested for a particular condition. In it is the case of a balanced bridge, and for making the bridge balanced, what is the necessary condition where the resistors are such that we have to adjust all the values of R1, R2, R3 such that we get current through galvanometer as 0. Can easily get the balance condition. And what is the balance condition? There is no current through galvanometer. This is called balance condition. In some books it is written as null condition also. In this case the Kirchhoff's junction rule applied to junctions D and B. We know we are having two rules for from Kirchhoff's Kirchhoff's junction rule. It means we will be dealing about incoming current and outgoing current. And second one is Kirchhoff's voltage loop rule. In that rule, we need to find potential difference for the closed loop, and their summation will be equal to 0. Now, studying about point B and D for the balance condition, and it immediately gives the relationships like I1 is equal to I3 and I2 is equal to I4. Next, we apply Kirchhoff loop rule to the closed loops A to D, D to B, B to A. And second loop is C to B, B to D, and then back to C. For first loop, you can say if you are going from A to D, we are going in the same direction as in the current, but here potential is more, here potential is less. That's why current is flowing from A to D. So we are reaching at low potential. So we put a negative sign minus, and this is the potential drop across the first resistor. And from Ohm's law, we know V is IR. So for this, we can write V1 will be equal to I1 R1. So that's why we put a negative sign I1 R1 plus. We know for the balance condition, current through the galvanometer is 0. So we put a 0 here. Now current is flowing from, now the current is flowing from A to B, but we are going from B to A so that our loop gets completed. So that's why now A is at higher potential and B is at lower potential. So if I subtract VA minus VB, I will be getting a positive value. So that's why a positive value is there. And potential drop for this resistor will be V2 will be equal to I2 R2. This is the potential drop summation, and that should be equal to 0 because हम लोग घूम के वही आ गए हैं A to D, D to B, B to A. So this you can say first equation. Similarly, for the second loop, you can say when we go from C to B, here potential is more at point B, so we will be getting a positive sign. So firstly, it should be plus I4 R4 plus, then we will come through galvanometer, but for the balance condition, current through galvanometer is 0, so it will be 0. Now we are going from D to C. Now this point D is at higher potential and this is at lower potential. So when you will be doing VC minus VD, potential C का कम है, D का ज़्यादा है, so we will be getting a negative value. That's why it should be minus I3 R3 and summation of all the potential drops will be equal to 0 because loop पूरा हो गया है, closed loop है. अब हमें पता है पहले वाले रूल से, किरचॉफ करंट रूल से हमें पता है कि I1 तो किसके इक्वल है I3 के, तो आप यहाँ पे I3 की जगह I1 रख सकते हैं. I4 किसके इक्वल था I2 के, तो आप यहाँ को हटा के I2 भी कर सकते हैं. सो दिस इज द इक्वेशन. अब इन दो इक्वेशंस को सोल्व कर लेना है. When you simplify, you will get I1 by I2 is equal to R2 by R1 from this equation. When you simplify this equation, you will get this one. And when you simplify this equation, you will get this one. I1 by I2 is equal to R4 over R3. जब लेफ्ट हैंड साइड इक्वल है तो राइट हैंड साइड भी इक्वल होना चाहिए, तो दैट्स वाई R2 बाई R1 इज इक्वल टू R4 बाई R3। अगर मुझे यहाँ से R4 निकालना है, क्योंकि वो देखो ये नो रेजिस्टेंस है, so that will be R2 R1 multiply by R3, and this is known as the last equation letting the four resistors is called balance condition for the galvanometer to give zero or null deflection। इजी है, थोड़ा सा समझ के काम करना है, और स्कोरिंग चैप्टर भी है, स्कोरिंग टॉपिक भी है ये। नेक्स्ट यू कैन से now the Wheatstone bridge and its balance condition provide a practical method for determination of an unknown resistance. So you can say why we are using Wheatstone bridge. If it is asked, you can simply say it provides a practical method for determination of an unknown resistance. Let us suppose we have an unknown resistance which we insert in the fourth arm. R4 is thus not known, or from the picture you can see. Keeping non-resistance values of R1, R2 in the first and second arm of the bridge, and we will be changing R3 till galvanometer shows a null deflection। तब तक हम लोग R3 की वैल्यू को घटा भी सकते हैं, बढ़ा भी सकते हैं। कब तक? जब तक हमें करंट थ्रू द galvanometer जीरो ना मिल जाए। The bridge is then is balanced, and from the balance condition we can find the value of a non-resistance. R4 is given by this equation. A practical device using this principle is called a meter bridge, and this is important from practical part.